Hey everyone, so this is the tutorial associated with Lab 4, and in Lab 4 we're going to use a lot of the same tools that we've been using throughout. This one is focused on points and raster data, so we're going to get some more point shape files. We're going to talk a little bit about cleanup of point shape files, because especially if you download data off the internet as a table of some sort, those can often have a lot of extra rows or columns that you don't need. And then we're going to talk a little bit at the end about how to translate information that you've gathered from your point shape files into a raster surface map. So this is sort of a very initial introduction to what in environmental conservation is called species distribution modeling, which basically means if you have a bunch of point locations for a given species, like one of these maple species. So these are all maples that I downloaded from the internet. I'll show you where in a second. So if you have a bunch of locations where a particular maple species has been found, and those locations exist in certain climate conditions, then the idea behind species distribution modeling is that you can use that information to create a surface, a climate surface that indicates where that species, other good climate locations where that species could potentially establish. So before we get started, just some information about where the data came from. So you should have this information, your maple shape files. I just copied this all into a working directory because we're going to be deleting stuff from the shape file. So I didn't want to overwrite my original data. So I just created an extra copy. And then you should also have these 4 layers of climate information. So those data came from the Global Biodiversity Information Facility, or GBIF.org. This is where all of the maple data came from. So if I search for Acer sugar maple, then I can look for occurrences of the sugar maple. I can say yes, because it's going to do a taxonomic matching that this is the nomenclature associated with it. So I want that. I want just my actual occurrence data, not the ones that are absence or anything else. And then I can also, there's a location thing in here. So I definitely want ones that include coordinates, not ones that say it was found in such and such county, or it was found someplace in Australia or whatever. And then you can also put in or draw in a geographic range, as you prefer. So, like say, I just want things from North America. And this sort of updates your results, and then you can download this information as just a simple CSV, which will include the coordinates as well as the species names and a whole lot of other things too that we'll see in a second. So that was the process that I did to get these maple data. I also downloaded the climate normals, so that just means an average over the 30-year 1991 to 2020 30-year average. You can download those from this Oregon State website, the PRISM Climate Group, which has created a bunch of interpolated climate models for the lower 48 states, going back to for the last century. I think it goes back quite a ways. And these are interpolated from weather stations, precipitation stations and temperature stations across the US. The normals you can either get 4 kilometer or higher resolution, 800 meter precipitation, mean temperature, blah, blah, blah. You can also get elevation here, or you can get monthly stuff. So lots of information to be downloaded. I downloaded these data as ASCII data. ArcPro reads in ASCII as is. So this is just another form of raster data. And ASCII is basically just text data in a table with a little bit of header information to tell Arc, where in the world this is located and how big the pixel size is. Arc Desktop isn't as big of a fan of ASCII files, so I converted everything into GeoTIFFs, which is what you have here. There's a convert raster tool in Arc Pro. In Arc Desktop, there's an ASCII to raster tool. So if you're in desktop and the ASCIIs aren't working for you, or these aren't working, you know, for your the lab that you're going to hand in, you can always convert things into TIFFs or into grids, however you like, using convert raster in Arc Pro or ASCII to raster in Arc Desktop. All right, so let's take a look at some of these data. So again, remember, I only downloaded the point locations that were in, you know, sort of a rectangle around the US. So this is going to include some points in Canada and stuff like that. But generally, it's just going to be in the lower 48 area. And then we can also take a look at what some of these other data layers look like. So this is our, for any given pixel, our average precipitation over the last 30 years. And I'm guessing that this is in millimeters, probably. Although we'd need to look that up. Actually, we can look that up. It probably tells us on here someplace. I'm not going to worry about that right now because I don't care too much. But generally, if you have a question about what a data format is, go back to wherever you found it from and look around for, you know, metadata associated with, you know, like frequently asked questions. It's probably in there. Okay, so what we're going to do is we're going to start out with a model, but we'll go through each of the different tools. So any kind of analysis that we want to do, again, I've got, in this case, you know, 7 different shapefiles that I've created, which means that I want to start out with an iterator. These are shapefiles to begin with, rather than CSVs, although when you download from the internet, when you get your own, you will probably get a table format. So you'll need to start out with that XY table to feature, or whatever the tool is called. In this case, we can start with an iterate feature class because we already have shapefiles to work with. So let's find our directory. That's the directory that I want. I haven't put anything else in this working directory, but I can always say, you know, I just want to work on the maples for today. Good enough. And I'm just going to run that again so that it looks in that folder and finds the name of the different shapefiles. So this is good. It's, you know, it's got a name here. It's run through Acer Saccharum, the sugar maple, so that means that it started alphabetically and went to the end. All right, so what we want to do next is get information from these temperature and precipitation data into our point shapefile. So you guys should remember the name of that tool because you just did it at the end of lab 3, or you might have done it at the end of lab 3, which is the extract multi-values to points. All right, so now that, because we've run through the iterate feature class, it should recognize this as a point features. This isn't going to light up yet because I also need to identify what are the raster data sets that are going to go into this. So basically what this tool does is you have a point shapefile. It has a bunch of fields, right, columns. When you tell it to append, basically extract these values to points, what you're doing is you're saying, all right, take whatever the value is of the pixel that is underneath that point and add it as a field at the end of this. So the nice thing about extract multi-values to points, this is true in Arc Desktop too, is that you can change the name of the field over here. So if prism underscore precip underscore isn't what you want, you can simplify that to be just precip. I'm just going to add all of these guys in first, and then I'll change the names. Right, so I want this to be Tmax. I guess So I already have a preset field from when I did this last time. So it's gonna only allow me to overwrite the others. Yours shouldn't need an _1 after these. I thought that I refreshed everything, but evidently I didn't, so it wasn't into that original name. Because it's going to each time append those fields, so we can double check that and see that. Yeah, so these fields already exist in here, even though they've been wiped clean. It looks like my refresh didn't work the way I was expecting it to. Hopefully yours doesn't have precip or anything at the end. Let's do an autofit so that doesn't look like quite as much of a mess. Okay, so if I run through this thing, then what should happen, so let's try doing it just with our single guy and a single precip. I'm not sure if it'll overwrite. Let's see if it'll do that. No, what's the new one? I'm just gonna call this temp precip for now, just so it doesn't mess up my model builder later on. When that runs, what we're gonna see when we open the attribute table is that we should have this temp precip 1 apparently at the end. My temp precip file. All of these values are whatever the precipitation was for that particular location. So there are a couple of things to notice when we just kind of look at these data. First is that there are some values with -9999, right? So that information is probably not precipitation. That would be a very dry place, right? Someplace that's like sucking negative 10,000 millimeters out of the air, or something like that. So these locations, and we can go look at them, probably, okay, so here they are up here. And so you'll notice that the reason that they have this -9999 value is because they're actually in the location where we have a no data value for the geotiff, for the prism precipitation. So even though it looks like this ends here, remember a raster is always a rectangle, so there actually are some raster data up here. We're just not seeing it the way that the data are displayed. They're displayed such that no data has no color, so we're seeing through them. These locations up in Vancouver are giving us this -9999 no data value. So that's an issue. Another thing that I'm noticing in here is that there are some places where we've got a whole bunch of values that appear to be the same for precipitation. So let's see where those are. All right, here. Right? And as we zoom in, we can see that, so you can kind of see the outlines of the pixel. It's a little gray on gray right now, but we've got at least these 3 points, and it looks like there's quite a bit more than 3 points, right? 14 points. These 14 points are on top of each other, is what it looks like. They're duplicates of the same points, and they're also duplicates of the same pixel. So in terms of trying to model the climate for a particular species, a lot of times we don't necessarily want, you know, 1 million duplicates or 2 duplicates or any duplicates on a given pixel, because that gives us sort of a false sense of what the average is for that species, right? If we're duplicating our counts of a single pixel, then that pixel is going to be weighted, if we take the average, a lot more than this pixel where there's only a single point, for example. So we might want to remove these duplicate lines in here so that we only have a single point per pixel. We just care about it on a pixel basis. So those are a couple of things to look at. The other thing that I notice in here is, gosh, there's a lot of junk, right? Like I have to scroll over a long ways. There's all this stuff that I don't really care about all that much. Like the main thing that I care about here is just like the species name. I don't care about the subspecies. I don't care about the full taxonomy or the authorship of whoever named the species and blah, 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 all this other stuff, right? So there's a bit more of a mess here than I really need. So let's talk about some of that data cleanup. So I have now set it up to extract multi-values to points, which means that at the end of my shapefile, I will now have those 4 new fields with my climate data. But then I want to do some additional cleanup on top of that. So the first thing is those rows, right? The rows that were duplicates, I would like to clean up those rows and remove the duplicates. That's a 2-step process because first we need to select them. So we need to do a select by attributes. And this is my input rows, and I need to tell it what are the ones that I want, right? So I want this where my, oh, right. And actually this is one where I'm going to need to run this up to this point first because it has not yet recognized that that precip layer is in here, right? So I'm going to validate this. I'm just going to run it for Acer barbatum. Acer bar is good enough so that I don't have to wait through the entire thing. Let's see what that error meant. And so hopefully, oops, now I can find that information at the end. Okay, so here's my precip 1 is the one that I'm going to choose. And so there's a couple of things that I can do here. One is, so there was that -9999, right? So I can say precip is equal to -9999. Another thing that we didn't actually look at is are the null values. So there are some values in some of these data sets, and you would find this later on. I know this because I just went through the process, where the values for these are null. And we don't want no data values, right? So -9999, those are ones where there's actually a point location where it extracted no data from the precipitation layer. Null values are ones where, you know, there was either no geolocation or it was outside, even further outside of the extents of that grid. So these are 2 things that we want to identify and delete. Okay, so we've selected our null values, our no data values, and our -9999s, the no data values, and then there's a delete row. Delete rows. And that should just basically operate on whatever's selected and spit out the exact same layer that we started with. I can't remember. Okay, there's no output. Yeah, so this was the exact same layer. We don't have to worry about the %name% thing because it's just operating on the same shapefile. Let me clean that up a little, get over here. Okay, another thing that we wanted to do, right, because we saw that there were multiple values associated with precipitation, is to delete identicals. So that essentially, a delete identical, you can run it across the entire data set, right? So across all of your different columns. So if there's any full duplicates, then just running delete identical with the defaults in is the way to do it. In this case, though, we don't actually want, what we want are ones that are in the identical pixel. And so in this case, the fields that we want to remove are ones that are the same for precip. And it's possible that there are some multiple precip pixels that have exactly the same values. So I'm going to put a couple of things in here. It's really unlikely that we would find multiple pixels that have the exact same values for all 4 of these. That's probably a little overboard. Probably we could get away with 2, but let's be extra careful here so that our output data set is just a single point on any of those pixels. And ARC will just choose the first record that it comes to. So when we saw before those 3 points on that single pixel, it'll just pick whichever the first one is. So if you really care about XY coordinates, another way you could delete identical is based on your XY locations and just say, like, I just want the first record at the same XY location. I don't care if it was collected over multiple years or by a different person or somebody put a different node on one of these or something. I just want a single one. In this case, we're going by the pixel. Okay, there is another tool that is usually really useful, which is called delete field. You can see there's a red exclamation point because I've been trying to beat Arc Pro into submission, and then I finally gave up Arc Pro 1. Delete field is not working in Arc Pro, at least in the version that I'm using right now. Hopefully they are in the process of fixing that. If you're using Arc Desktop, delete field is working totally fine. So I'm not going to run this because when I have run it, it has basically crashed and then corrupted my data file, which is not a great feature of a tool. But I want to show you how it would work anyway. So basically, if you have the input, you can tell it to drop like all of these fields. You can just say, like, I don't want any of these except, there's so much stuff here. All that I want is, we looked through before, I think, and we saw that species. So I want to keep my precip. Species was the species name, and, my 3, pieces of information about climate. You cannot, there's usually like object ID, there's often an object ID or an FID in here, which is associated with the, I don't see it right now, but it's probably in there someplace, that's associated with the shapefile itself. That's one field that you're not allowed to drop, so you can't drop the OID or the FID fields if you wanted to. And theoretically, if you did this, and hit, and it's slowly turning through these. Delete field is also a pretty slow tool. Then this should clean up that data file, or I could connect this in if I were normally doing that. I'm not going to do that because I know that it's going to break it. So if you are watching this post 2021, hopefully the delete field tool has been fixed in Arc Pro. Or again, if you're in desktop, feel free to use the delete field and get rid of a whole bunch of stuff that you don't need. Cool. So this should now, I have my iterate through all of the different files, although right now it's just doing this first file. It is extracting all of these values to points. Then it is selecting my no data values, my -999s and my nulls, and deleting those. Then it is deleting any identical points in there. And all of this is happening to that same initial layer. So it's not exporting a new shapefile. So be a little careful when you go through these, because there's no easy way to go back, right? Other than to go back to the original file itself, which is why I stuck all of these in this working directory and made a copy of them over, so that when I screw it up, which invariably I will, I can easily go back and copy over the original ones again. Okay, so this should just run on the Acer bar bottom, but I'm just going to go ahead and run that thing. And let's see if anything happened. And empty outputs are not always the best thing to see. Okay, I screwed something up. All right, so let's go back a step and I will try to figure that out. Okay, I figured out what was going wrong. A couple of things. So first off, when you run extract multi-values to points the first time, it will not allow you to overwrite the same output field name a second time. I tested that in a geodatabase as well as a shapefile, and it's true for both of them. So it actually doesn't matter where you're running this. So if I run this the first time for this one, I was just setting it up so that it ran for Acer Barbatum. If I run this the first time, and then I try to run it a second time because I messed something up down the road, then it will automatically change these to precip _1, tmax _1, tmean _1, and tmin _1, like we saw that first time that we were going through. So in order to fix that, you need to basically delete the fields, or what I've been doing is copying this over into my working directory each time I screw it up, so that those fields are not there anymore. So this is my fresh or original, I guess, not so fresh, my original file that doesn't have that climate data appended at the end. So then the model will be happy and allow you to just call them precip, tmax, tmean, tmin. The second thing that I was doing wrong was I had this rather than as, okay, let's try that again. Rather than having this as an or statement. Okay, so here's the issue, right? When I initially ran it in, when I initially had to run it so that precip was actually a thing that I could connect into select layer by attribute. But that messes the thing up to begin with, right? So I could either call it precip1, as long as this is consistent with what the original thing is, we're okay, but you're gonna have to mess around with it a little bit. So that this says, because right now it gives me that error because it doesn't even see the field precip as an option. So what we did initially, so here we can just do the full step through. So I will just run this initial one, right? So I've got now an output here that I can put into my input rows, and then I'll be able to select precip is equal to -999, precip is null. Before it defaults to and. There is no and, right? There's no place where precip is equal to both -9999 and is also null. So I want this to be or. The other thing that happened, and I don't know why, is that this was turned on. And so invert means do the opposite of what these things are saying. You don't want that checked. You want to do what these things are saying. So now the problem being, if I try to run this again, or I open this tool, you can see that it's now exporting with this one field. And it in fact won't let me change it back to precip because it recognizes that precip is already in Acer Barbatum. So, you know, annoying, but that's the GIS likes to mess with you sometimes, right? So I'm just gonna copy paste that file over here. Oops, that's not what I wanted to do. Delete it first. Delete this other one because I don't need a copy of the thing. Let me get this new guy back over here. And so now the model should be set up just fine. It's just that I now have a totally new file that I can open and just double check that it doesn't have any of those precip or temperature columns in it. That's good, so it's gonna work in my model. I've called this precip them capital PPT, etc. I'm selecting that particular layer, either of these conditions. I'm going to delete, and then in my delete identical, I also am using those fields of capitals, precip, tmax, tmin, tmean. Okay, so now hopefully this whole thing will run for if I chose. In fact, let me just go ahead and do that. Let's do this for all the Acers so that we don't have to run through that rigmarole again. And we'll actually have all of the data. So off we go. All right, so that took about 2 minutes on my computer to run through those 7 species. So let's see what happened. Okay, so first thing to notice is, because this was the file in the working directory, we should be able to move over the original. Right here was our original file in terms of locations, and you can see that now there's only a single point location per grid cell, right? This is on the grid cell next door. It's hard to see with these grays, are so close to each other. Also, the original maple had 183 rows associated with it. Our new cleaned up maple has 119 rows associated, right? Because we deleted those identical places with identical precip temperature and any of our null values or negative 9999 values in there. Okay, so here's our cleaned up value for this particular one. I'm just gonna remove that so we don't even have to look at it. Let me make these a little bit more visible, bright red circles, and let's see what the whole distribution looks like. Okay, so there's our distribution across the US. If we want to, so our next step, so basically now we have a cleaned up, except for the delete field piece, reasonably cleaned up data set that we can use to try to understand what climate conditions are like in areas where these different maple species exist. So remember, my precip, Tmax, Tmean, Tmin should be over on the right side. So this is a place to refresh yourself with the statistics tool. And in ArcPro, the statistics tool is really very nice because by default, they produce this nice little histogram for you that you can check out. Rather than in Arc Desktop, you have to do that as a geostatistics tool, and there's a bunch of silly steps associated with it. So ArcPro, good job on this one. The kind of fun thing about histograms, right, is, so again, a histogram is binning all of your data into these different bins of precipitation so that you can see the precipitation range associated with this species. When I look at this histogram, I see a couple of points that are really down on the dry side of precipitation that I might consider to be outliers. And I can click on them here and that'll select them. Also a nice feature. Okay, so we've got like one of these plants in Los Angeles, it looks like. We've got another one kind of up in a apparently dry part of Michigan. And then we start getting into sort of, okay, those look like they're within the kind of scope or the area where most of my data are falling. Which means that if I want to say that Acer Bar Bottom has, you know, a minimum precipitation requirement, I might choose to disregard these 2 points because they feel like, oh, they're kind of far away from the bulk of the data, and I really don't know about this LA point, you know, like whether I trust that or not. So instead, I am going to choose, and all of this is up to you. You're the modeler here, you're the decider. As long as you justify your decision and include that decision in your methods, then you can do whatever you want here. So I'm going to choose 959.5, evidently, as my minimum precipitation value. And the maximum precipitation values are down here, looks like in the Gulf Coast. So our max goes to 1610 or thereabouts in terms of precipitation. So that seems like a reasonable top level to deal with. So there's precipitation, and then let's also go with, I'm just going to do mean temperature for this example. There's my selected ones, right? You can see them in here. So I can select from the map and see where they fall in the histogram, or I can select from the histogram and see where they fall on the map. This one looks awfully cold. There's a couple of points up here. So one is that Michigan point, which was a little sketchy, and another is up in New Hampshire or Vermont or something like that, which also seems kind of fringe or like the edge of the bulk of the distribution. So let's see where this one is. Yeah, I mean, that feels like it's kind of getting into the distribution, but maybe I want to start here where I start getting a couple of more points in the core of the distribution. So that's 11.2 as my mean temperature. Those are going to be in Celsius. And then my max of down in Florida of 22.4 in terms of temperature data. All right, so I've written those down, 959 to 1610 in terms of precipitation, 11.2 to 22.4 in terms of mean temperature. So our next piece now is to take our raster data that we have, these prism climate means and make a map of what that surface looks like. Where in the world, or where in the lower 48, I should say, do we have these conditions that overlap each other of 959 to 1610 precipitation and 11.2 to 22.4 in terms of temperature? So let's see if we can do that. Anytime you have sort of ranges of values associated with a raster grid and you want to create a new grid surface where you have true and false, right? Ones for true, zeros for false. The tool for doing that is our raster calculator. You guys might remember messing around with some raster calculator things early on. So I'm going to add my raster. Let's see if I can get this. See if I can get the syntax on a single take. Okay, so I've got my precip in here. I also want my t-mean in here so that I can play with it too, because that's the other one that's gonna work in here. So I want to say that precipitation, I want that to be greater than 959. And I want my precipitation to be less than 1610. And there should be an and in here. Actually, it might be an ampersand. Oops. Just kidding. Ampersand. Ampersand. That's such a great word, right? Reminds me of Pat Sajak and Wheel of Fortune anytime I hear that word. All right, and my t-mean, I want that to be greater than 11.2. Ampersand, my t-mean to be less than 22.4. And let me call this Acer barb. I think that's good enough for now. Let's see if this works. Okay, miraculously, we got the syntax right. And so this again is giving us this true-false layer where ones are true, all of these conditions are met, and zeros are false. We're not either none or one of these conditions is met, but not all of the conditions are met. And if I can compare this, I can put my Acer bar bottom up on top of this, then I should find, let me clear the selection so there's nothing a little wonky going on. What I should find is that there are, some areas in here that are falling into the false, right? The zeros, and these were the ones that were sort of too cold. What's interesting actually is if I go in here, there actually are a couple of purple spots around here that fall into that climate range. So it's possible actually that this LA point is in some sort of like microclimate where it's wetter, a fair bit wetter, like at a higher elevation or something. And we're just not capturing that with these general climate data. And we have a bunch of areas in the Western US that appear to be warm and wet enough because they're up in the mountains. And then basically this whole chunk in the Southeast. So that is for this single species, how to get the information from our point data, understand kind of what's going on a little bit there so that we can delete data that are going to give us a false sense of what's going on or are going to mess up our statistics at the end, and then get that information into Raster calculator so that we can create a map of areas where we might expect, based on the climate conditions, to find Acer bar bottom. You could certainly do the statistics for t-min and t-mean and add those statements on here in terms of your raster calculator. That will reduce the land area in here a little bit more and maybe make it a little bit tighter relative to where your points are. And one of the things, this is just like an extension, but what scientists use this type of modeling to do a lot of times is first to try to figure out suitable habitat. So where might we find this species? Where are areas that would be good to conserve for this species? Another thing that people are using this a lot for these days is to try to understand how these distributions might change or shift with climate change, right? So if climate is warming, we might lose the southern edge of the distribution and gain more in the northern edge of the distribution. So where are areas that we should be thinking about, facilitating or expanding these populations, or maybe giving up. There are some areas that we might give up because the climate is going to become too warm for them. Cool. So hopefully that's enough to get you through from distribution data to a first order climate model. I will see you in class, and we'll go through this in class on Wednesday. Thanks.